Okay, so we're going to go into equivalent expressions. Now on the right here, you'll see a bunch of predetermined cofunction identities, and at the end of this video, I will explain how they got them. Keep in mind that these two pretty much come from these two, and that these two are pretty much the same thing. So it's really the first three that matters. But we'll get into this, I'll explain it at the end, and it all relates to the unit circle. Let's look at this question. State an equivalent expression in terms, and this is the important part in the red box, in terms of the related acute angle. So the first thing you should do is understand what's an acute angle and what is a principal angle. And those are the two things that we need to understand. So here's the unit circle. And the thing about the unit circle is when you start any measurement, you start it right here. Right here. This is essentially called the origin of it. And we don't move clockwise, we move counterclockwise. Now it's clear to me that as I move this around and go around, if I keep that arm length the same, let's call it 1, length of 1, as I go around and around and around, length of 1, I'm going to create a circle, right? And that circle is going to be a perfect distance of 1 wherever I am. Now it's very clear that on the axis, I'm going to create 4 distinct points because the length of that terminal arm, remember, is 1. It's going to reach 1, 0 here because the terminal arm is 1 long and it's not going up the x-axis. And of course, if I draw the terminal arm up here, I reach a point of 0, comma 1. And as I go around these points with the arm, the points become clear. And actually, I just want to get rid of that red line in there. There we go. So here I would get 0, 1. Now here I'm moving to the left. So I get minus 1x, 0. And that's going to explain why a lot of it's going to explain the cast rule. So I'll get to that in a second. And of course down here I have 0, minus 1. It's also clear that if I draw this arm, this terminal arm it's called, and then I draw an angle straight down here, that is going to be called my principal angle. Why? Because it started from origin. So the principal angle, right away you should note down, the principal angle is the angle from between the terminal arm and essentially the origin, the start of it. Okay, even though origin 0, 0 in the middle, the origin in terms of trig is this line right here. This is where we start, 1, 0. It's also clear that if I stop there, right, anywhere, before in the first 90 degrees, I'm going to stop there. If I take a measurement at this point in the circle, I'm going to have an xy value right at this point here. It's going to have an xy value right there. Okay? It's also clear that I can draw a line straight down, and we'll make it in blue so that we can see it. And I can also draw a line straight over there. And the angle that we're talking about, the principal angle, is also right there in this triangle. It's also clear that this length here of this triangle is the x value in there, because it only goes that far out, the x. It's also clear that this thing right here is the y value. And also keep in mind that we made the arm of this circle 1. That's really important. It's also clear that this is a right angle triangle, and that 1 is the hypotenuse. Now here's where SOHCAHTOA comes in. SOHCAHTOA says that the sine of this angle here, now keep in mind that this is y over here, this height right here, the sine of that angle is equal to the opposite over the hypotenuse. But also keep in mind that our hypotenuse is 1 over and over and over again. So we don't even have to include that division by 1. So that means our sine is equal to our opposite side divided by 1, or just our opposite side. Our opposite side also happens to be our y value, which means the sine of any angle is going to, and I shouldn't call it x, let's call it, that's why they don't use x, let's call it an alpha, or I wish I had we'll just use that. Sine of this angle is equal to the opposite, but it's also equal to my y value, which is why ultimately we discover that the y value of anywhere in this unit circle is the cos is also the sine value. So the y value is also the sine value of the angle that we're talking about. And of course the angle that we're talking about is right here. If we use SOHCAHTOA now, we know that cosine is equal to the adjacent divided by the hypotenuse. But again, the hypotenuse is 1. And in this case, our adjacent to that angle is our x value over 1, which is just our x value. So we discover that the xy coordinates over here also happen to tell us the cosine for x and the sine for y. All right, if you don't believe this, I can show you more proof as we go, but I just want you to accept that. Okay, so that's one thing that we're going to keep in mind for later on. Let's go back. As I continue with this terminal arm, it's clear that some angles are obvious, right? So if I go from here all the way to here, I've gone 90 degrees. It's clear that that's 90 degrees, my little alpha angle. And if this is sine, that means that sine of 90 is 1, and we'll prove it later on. And that cosine, if this is cosine of 90, is 0. It's also clear that I can go past 90 degrees with the terminal arm, and here's the important part. I can go past 90 and go, boom. As soon as I go past there, I'm beyond 90. Also keep in mind that our arm is always anchored to the center of the circle. Okay? So once I go there, it's clear that this angle here, that the principal angle, is more than 90. I could even shade it in pink, like this. That's our principal angle. And actually, let's use just down here. That's our principal angle, right? The acute angle, which is also an angle less than 90 degrees, can only occur over here. This is the acute angle. That's the only angle that relates to this that could be acute, and it also happens to go straight to the x-axis. And why would we use that? Well, remember that I have an xy value over here. And that xy value is going to be related directly to the sine and cosine of this angle. But if I draw another triangle right here, straight down to the x-axis, and let's use blue again, I discover that there's a triangle that also reaches that, or an angle that also reaches that same x and y value related to the x-axis. In other words, if I took a blue line and started here instead and moved up to the same spot, I'm going to hit the same x and y spot with this blue arm, which is the same length as 1 and the same length as the principal angle. But this is a whole new triangle I've drawn from over here. So I will color that angle in blue. This is the acute angle that they keep talking about. And it's drawn straight down and straight across. But notice it will have the exact same x and y values as my principal angle. They will have this here, which is associated with this angle, will have the same x, y values as this blue arm. And it's quite obvious because this blue arm ends in the same spot. And it also is clear that the SOHCAHTOA rule for this angle applies, this triangle, because it's right angle, which means the sine of my blue angle, we'll call it the acute, is going to be y over the hypotenuse. But the hypotenuse is 1 again. So it's going to be y again. It's opposite over the hypotenuse, which happens to be y over hypotenuse, which happens to be y over 1, so it's y. And my cos of my acute angle is also going to be the adjacent over the hypotenuse, which happens to be x over the hypotenuse, which happens to be 1. So it's x. So this acute angle shares the same xy values as the as the principal angle, as the red angle. So the acute angle will share the exact same cosine and sine values because x is cosine of any angle and y becomes the sine. If they share the same x and y values, they share the same cos and sine values. The sine of this angle will be the same as the sine of that angle. the cosine of this blue angle will be the same as the cosine of that red angle. That's why we have what's called equivalent expressions. But since this thing asks us to find the acute angle, we should go through this process each time for each of these angles in order to find an equivalent. Keep in mind we can do co-function equivalents or we can do exact, but regardless they want us to use or find this blue angle. Great. Now that we understand the acute angle in terms of the principal angle and that they're different, the acute angle is always here and the principal angle is always here. Also keep in mind that sometimes the principal angle and the acute angle are the same. This occurs in quadrant 1 only. Quadrant 1 only. And that is why we have A for the cast system in here, and we'll get to that in a second. So that means in quadrant 1 only, the principal angle and the acute angle will be the same, and it's obvious when you use the blue. So the blue angle here is going to be the same as the red angle. So that's the first thing you should note is in quadrant 1, the principal angle is the acute angle. And that's the thing our calculators will always spit out. It'll spit out the angle that's closest to the x value, to the x-axis in the quadrant that it's in. So for instance, if my principal angle is over here, the angle that my calculator spits out is always going to be the acute angle, which happens to be in quadrant 1. Your calculator always spits out what's essentially the acute angle. So that's why you get two angles. You'll get the acute angle and you'll get the principal angle. There's always two angles because they share the same x and y coordinates. That'll explain to you why there's always two angles in here. And we'll get into that more. Essentially, look at it this way. If I have 120 degrees here and this whole thing is 180, it's clear that this little blue angle here is 60. And if I punch 120 into my calculator and press sine, I'm going to get the same as for 60. So let's try it. So 120 sine, I get that 0.8660. Now let's do 60 sine. I get the same thing. And you can discover that's true no matter what angle I draw. The sine for this big angle will be the same as the sine for this acute angle. So that's the first thing. But you might say, how come some of them are negative? Why do we have the cast system? Well, notice that the x value in this area is negative. So that means any triangle I draw in here for the acute angle will have a negative value on this part, on the x value. So that means every time I use, and it'll have a positive here because y values here are positive, and the hypotenuse is always positive. So that means when I take a sine value, which is positive over positive, it's going to come out positive. That's why sine is always positive in this area. But if I take a cosine, which is adjacent over the hypotenuse, I'm using a negative value, which means cosine is always going to be negative in this area. And what about tangent? Well, tangent I'm taking opposite over adjacent, so tangent is also going to be negative. As a result, all their flips are going to be, all their reciprocals will be positive or negative as well. So cosecant is the reciprocal of sine, so it's going to be positive in this quadrant. But secant, which is the reciprocal of cosine, is going to be negative, and cotangent, which is the reciprocal of tangent, is going to be negative. And that's why we have the cast system. And as you proceed and you go down into the next area, into the next quadrant, let's say we draw a line down here, and we look at this triangle right here. Well, now on my y value, which is going down, is negative, and my x value, which is going to the left, is also negative. So here, if I take tangent of this angle here, which is opposite over adjacent, I get negative divided by negative. So tangent is positive here. But if I take sine, and remember my hypotenuse is always positive, if I take sine, which is opposite, negative, over hypotenuse, positive, sine is negative. If I take cosine, which is a negative value divided by hypotenuse, I get negative. And that's why in the cast system, the first quadrant, everything is positive because all the x, y values in the first quadrant are positive and positive. In this area, sine is the only thing that's positive, and that's because all my x values are negative, and x values are used in tangent and cosine. And my y values are positive, and the y values are used for sine. When I get down here to tangent, I just showed you all my x values are negative and my y values are negative, which means my sine and my cosines are going to be negative, but when I divide my tangent, I'm going to get a positive. And finally, in this area, y is cosine positive, because if we draw a right angle triangle over here, we can see that the x values right here are positive. The hypotenuse is positive, but the y values are going down to this point here on the circle. It's always to a point on the circle. And the y values are negative, and that's why cosine, which is adjacent, positive, over hypotenuse, positive, is positive, and everything else is negative. Also keep in mind that this is where tangent equals sine over cosine comes from. Because as we learned from a triangle, let's go back to here, as we learned from a triangle, over here, tangent is what? In SOHCAHTOA, it's the opposite over the adjacent. It's the y value here over the adjacent, the x value. But we learn soon that the x value is the same as cosine, and the y value is the same as sine, the sine value. So if tangent is equal to opposite over adjacent, and the opposite is y, and the adjacent is x, and y is also the sine, and x is the cosine, we come up with this. Tangent is equal to the sine over cosine. And that's why if I were to take 30 degrees, let's say, and find the sine, and then it's 0.5, memorize it, and then take 30 degrees and find the cosine, it's that, let's memorize it, or let's just keep it in there. Now let's take this and divide it by, so I'm just going to, actually I'm going to reverse that. So it's sine first, yep, and cosine. So cosine of 30 degrees is this. Memorize it. Sine of 30 degrees is this. We're going to take sine, and we're going to divide it by our memorized cosine. That's incorrect. I memorized the wrong thing. So 30 degrees cosine. There we go. Because it added the two memories. And now I take 30 sine. And I'm going to take sine and divide it by my cosine value. Again, I forgot to clear. I've got to clear my memory. Sorry about that. So I'm going to memorize this in a clear memory now. I'm going to take sine of 30. And I'm going to take it and I'm going to divide it by my cosine. And I get that, 0.577. Just remember that. Now, what happens if I take 30 and just click tan? I get the same value. You can prove it over and over and over again to yourself, but that's why tan is equal to sine over cosine, because tan is equal to opposite over adjacent, and the opposite is y, and the adjacent is x, and y happens to be the sine value, and x happens to be the cosine value. But let's move on from that and get to this. Let's start with the first degree. So first you have to understand how to convert radians to degrees if you don't know where that is. And I'll just tell you right now that a circle, if you go around, the formula for a circle is pi times 2 times r. But remember our unit circle, we're using a 1 unit for the radius the whole time around, which means r in the circumference of the circle is 1. Which means the circumference all the way around is 2 pi times 1, which is just 2 pi. So if the circumference around a circle is a unit circle is 2 pi, and radians, angles measure this area in here. Radians measure what's called an arc, or part of the perimeter. Part of the perimeter. If I was to measure the entire perimeter, we would know that 2 pi is the measurement of that blue line all the way around. And that's what radians measure, a piece of the blue line all the way around. Well, that means if we've gone 360 here, 360 is the same as 2 pi radians, or 2 pi of the circumference. And they put radians here because if we use a different radius, we would just multiply the 2 pi by that. Okay, we're going to stick to 1 radian, 1 unit circle. So that means 360 is equal to 2 pi. What's half of 360? 180. What's half of 2 pi? Pi. which means 180 just to here is the same as pi. Great, so we have some equivalence, which means halfway around is a pi radian. All the way around is 2 pi radians. Well, if half the way around is a pi radian, let's bring that back because that was useful, that other one. It's not going to come back now. Oops, there we go. Well, I lost the other one, but that's okay. You can rewind if you need it. So that means this arc around this circle, that's what a radian measures, is 1 pi around. Well, what's 90 degrees then? Well, it's half of a pi. Pi over 2. So right away we get some idea of what we're at. 90 is equal to pi over 2. And I don't have a pi symbol ready on the typewriter. 180 is equal to pi. We know 360. We know 360 is equal to 2 pi. And the last thing, well, 180 plus 90 is 270. So it's going to be pi over 2 plus 1 pi, which happens to be 3 pi over 2. If you don't know how to add fractions, go learn how to add fractions. That's an important part of this. So we get some equivalents in case we want to know. Well, let's look at this first one, 3/4. 3/4, where's that? Well, 3/4 is less than 1, but it's more than a half. Where does less than 1 but more than a half fall in a circle? So remember that this is pi half, so this is 1/2 pi, and that this is pi, or 1 pi, and that this is 3/2 pi, and that this is 2 pi. So we're looking, where does the half fraction and the 1 fraction? Well, 3/4 falls in this. That means we're in quadrant 2, and the acute angle we're looking for is this. But this is the principal angle. So here's the principal terminal arm. We know we're here, and we know that's the principal, but look, they want the acute angle. So that means we need to find, what do we need to find? The angle that's less than 90 degrees that goes towards the x-axis, this angle. We need to find that angle there. We know that the principal angle is the red angle. Well, they've given us the principal angle. This is always the principal angle. So that means they're telling us it's 3/4 of the way over there. And if we want to find out the degrees because we're confused, here's the formula. You take 3/4 pi, and you multiply it by 180 divided by pi. The pi's cancel out. You can see that 4 goes into 180 45 times, so the 4, 45, and we get 3 times 45, which is 135. So really, we're also dealing with the 135. And this will just help you if you have trouble, but you should learn your radians and use these while you're learning them. Which means, if my principal angle has gone 135, I should write it in red. In other words, if it has gone 3/4 pi, how much is left? Well, all the way around is 180, and we've gone this far, which means the blue angle in here is 180 minus this angle. It's 180 minus 135, which is 45. 45. To do it with pi's, you know that 90 degrees is 1 pi. So you do 1 pi minus 3/4 pi, and you get 1/4 pi, which is the same as 45 degrees. So we know this acute angle in here is 1/4 pi. We're halfway there. It's 1/4 pi. Well, now that we know the acute angle, we need to find the equivalent. Since they share the same x and y values, that's going to help. But also keep in mind cast. Always keep in mind cast. What's going to be positive in this area? Sine. What are we dealing with? Cosine. So that means if the acute angle is always positive, and keep that in mind, the acute angles are always going to be positive because they all fall in the A area. So if acute angles are always positive, you have to know that sometimes we're going to have to multiply them by -1 to make them equivalent. Let me give you an example. Yes, right now, and I'm going to clear out everything actually. we know that we're dealing with this principal angle. And yes, we know that principal angle is 3/4 pi. And yes, we know that we're looking for the acute angle, and we've determined that that acute angle, and actually when you're dealing with radians, I should actually circle the outside, but I'm going to just circle the angle area. We know that that radian angle there is 1/4 pi. So I should have pi in there. But 1/4 pi. 1 pi over 4. So that means that my cos values of 1/4 pi will be the same as my cos values of my 3/4 pi, with one exception. My cos values of 1/4 pi are always going to be positive because it's the acute angle in the first quadrant. 3/4 pi falls in this quadrant where cos is negative. So that means that cos 3/4 pi is not equal to cos 1/4 pi, but it's equal to cos 1/4 pi times -1. The easier way to put that is we just put negative cos 1/4 pi. So right there I have found an equivalent using my knowledge of cast and my knowledge of the unit circle. That could be good enough for your teacher right there. So that means one of the equivalents for this one is cos -1 times cos 1/4 pi is equal to cos 3/4 pi. Right there. That's an equivalent. That's a totally legitimate answer to this equivalent. There's my acute angle. I've adjusted for cast, and it's equivalent to this. And if you don't believe it, take 135 and press your cos. You're going to get a negative value. Negative 0.7077. Now when I do 45 degrees, I'm going to get a positive answer, but the same value. 0.70707. To make them equivalent, I have to multiply this by -1. Now they're equivalent. That's what equivalent means. One value on the left must equal the value on the right. Well, the value here is negative. This is negative, and the value of this part here is positive. So to make it equivalent, I have to multiply it by -1. But what about things that aren't cosine that are equivalent, like tangents? And notice the tangents equivalencies only relate to other tangent equivalencies. But sine can be related to cosine, and cosine can be related to sine. And that's because as I go around this unit circle, let me explain why that's so. Here's the explanation of why that's so. Let's focus on the first quadrant. Here's the first quadrant. And let's focus on drawing one of those triangles, those exact value triangles. So I'm going to just do this, and I'm going to make it in blue, and I'm going to just adjust it horizontally. There we go. And keep in mind that it's going to reach a point on the unit circle, which I'll draw in red. And the only reason we draw the triangle this way to get to origin is so that we can match the hypotenuse arm of the red angle. And it just happens that if I was to draw a terminal arm, this triangle will match it. Let's look at the 60 degrees here. 60 degrees, we discover if we pull up our exact values, we'll have an x and a y value right there. But notice that what's the leftover angle over here? 30 degrees. That means we can form another triangle here that will have the exact same y and the exact same x as this blue triangle. You're going to discover that sine of 60 is going to be equivalent to the cosine of 30. In other words, the cosine of 90 minus 30. I can go into huge detail why this is so. But you're going to find this connection between sine and cosine in the first, second, and third quadrant, but you will again have to adjust for cast for the negative and positive. But it'll always have this relationship. How do they phrase it here? Well, sine x is equal to the cosine, and this is 90 degrees, minus the same angle that you used over here. Okay, if I trust that this is true, and I go back to this, and I can go into a huge discussion about how to prove this using the little triangle as I just did. But if I trust that these are true, and I've already determined that cos 3/4 pi is equal to negative cos 1/4 pi, then how do I find a sine equivalent that's equivalent to either of these? Well, I use this formula. It says sine of the value I'm looking for is equal to the cos of the value that I have. Let's use this one because it's easier to work with. So I'm going to use sine is equal to pi is equal to cos of pi minus the angle I'm looking for. Well, let's reverse that and use our known values. Cos of 3/4 pi is going to be equal to, we'll use this one here, sine minus sine of the value I'm looking for minus this value, 3/4. Well, not the value I'm looking for. I got to use pi over 2. Sorry, pi over 2 minus 3/4. Well, now we need to use some fractions. Pi over 2 minus 3 pi over 4. I have to cross multiply. I get 4 pi minus 9 pi over 12. 4 pi minus 9 pi is equal to minus 5 pi over 12, and it can't be simplified. The problem is that an acute angle. It happens to be down here because minus is this way. So I have to determine, is this more than half a pi or less than half a pi? Well, half a pi would be 6 over 12. So that means I'm dealing with the equivalent that's right down here. And that equivalent angle here is 5 over 12. Is that right? Let's do make sure we got our math. Let's try it with the other one. And before I get in there, let's try it with another one that's positive. Let's use the acute, the other angle that I found out this is equivalent to. We'll skip the negative for now. That's only important for cast. Let's use this quarter. Well, cos 1/4 pi is equal to, according to this, sine of half a pi, pi over 2, minus 1/4 pi. So we just have to, again, do our fractions. So what's pi over 2 minus pi over 4? We have to multiply this one by 2. So we get 2 pi over 4. Top and bottom we have to multiply by 2. Minus 1 pi over 4. So these have the same denominator. What's 2 pi minus 1 pi? 1 pi over 4. So we're talking with about 45 degrees again. 45 degrees is the only time where cos pi over 4 is equal to sine pi over 4. That's why it came out as the same. 45 degrees is the only time sine and cosine will be equivalent. But here's the problem. Sine in this quadrant is positive, and cos of this is negative. So that means for this to be true up above, it's equal to sine of pi 1/4 pi, just like cos 1/4 pi, but I have to put a negative in front of it, just like I did for this one. You might say, I don't understand why this is negative cos and this is positive cos. That's because this 1/4 pi falls in quadrant 1, where cos is positive, and this 3/4 pi falls in quadrant 2, where cos is negative. So you have to make these multiplying adjustments. Let's see if this is true. If I put in sine of 45, will I get the same value as cos of 3/4 and cos of 45? By the way, to do radians, there's a radian button right there. Click. And you can actually do pi divided by 4 and click sine. So there's my pi, or my sine of 1/4 pi, 0.7. Let's find cos of 1/4 pi. Pi by 4 equals cos. Same value. Now, let's do 3/4 pi. So 3 divided by 4 times pi equals. Now we're going to do trig cos. I get the same value, the same number, but negative. That means for this to be the same as that or that, I either have to multiply this by negative, but I can't because they've given me as positive. Therefore, I have to multiply this and this by negative. But that way, they'll all be equivalent. Let's do the next one. I'm going to just draw a fresh unit circle. Helps if we keep these equivalents as well. So you can always find on YouTube as well a shorter, more accurate explanation. Sometimes more confusing. You got to pick and choose your battles. But we'll keep the cofunction equivalency. Keep in mind your teacher would accept just cosine is equal to cosine because they've only asked for acute angle. But I want to teach you all of it. So what about this next one? Tan. How do we do tan? We follow the same rules. What's our first step? Find the acute angle. Find out what quadrant this falls in. Okay. Well, what is pi 11 over 6? It's more than 1. It's 1 and 5/6. That's quite a bit. That looks like it's almost 2. So immediately guessing, I'm going to say it falls in this quadrant here. But let's make sure. Let's do two things. Let's convert it to degrees. We multiply it by 180 divided by pi to convert to degrees. Pi's cancel. How many times does 6 go into 180? 30 times. What's 30 times 11? 330. 330 is more than 270, which is there, and less than 360, which is there, which means it's there. If I went all the way around to 330 degrees, how much is this angle here? And what is this angle here? This angle here is the acute angle. The acute angle that I'm looking for. How much is it? So I'm just going to work in degrees first, just to keep it simple. How much is that? How would I figure out if I've gone all the way around with my terminal, my principal angle? The red is the principal angle, 330 degrees. How much is left in this blue acute angle? Well, it's 360, which would be the full way around, and then go back to 330. 360 minus 330 is 30. That means this acute angle is 30. Well, let's work in pi's instead. I know that 330 is 11 over 6. How much is the full thing? Well, it's 2 pi. So it's the same process. I'm going to take 2 pi and subtract, ignore this, that's not a negative, subtract 11 over 6 pi. To do that, I must put this over 6. So I multiply top and bottom by 6. I get 12 minus 11, 6. So I get 1/6 pi. That is indeed the same as 30 degrees. So that means this area here is 1/6 pi, which means my acute equivalents are all going to be 1/6 pi. Okay, let's see what we can figure out about cast now. So that was step 1, figure out the acute angle. Step 2, figure out cast. So step 1, figure out the acute angle. That's always the important part. Step 2, use cast to figure out sine, cosine, tan, positive or negative. And what is the question asking us about? It's asking us about tan, so we should focus on tan. C, A, S, T. Tan is positive here, which means the acute angles and the principal angles will both be positive. That means I don't have to do any negative minus correlations. That means I can immediately say that tan of 11 pi over 6 is going to come out the same in my calculator as tan of pi over 6. That right away is an equivalent. Let's see if our calculator, if this is true. Let's take pi over 6. Clear your calculator. We're going to take pi, we're going to do it radian measure, so make sure your calculator's on radians. Pi divided by 6, and we're going to take its tangent. And we get this number, 0.5735. Let's put it in memory so I can remember it. Then we're going to take 11. We're going to divide it by 6. We're going to multiply by pi, which is the same as 11 pi over 6. We get this. Oop, I got to try it again. 11 divided by 6 times pi equals. And I'm going to take the tan of it. O-Y-C-A-S-T. Let's try that again. See? Oh, stupid me. I'm sorry about that. I don't know why I did the cast wrong. C A S T. Cosine's positive here. Tan is negative. So that means tan, if I put it of 11/6 pi, is going to come out as negative. But tan of the acute angles are always positive. So tan of pi over 6 is always positive. That means to make this equal to that in terms of its result, I have to multiply this by -1 because I'm looking at this is fixed. This is what I can't change this one. I have to change this one. So my bad. That was a big gaffe to have on video, but whatever. People make mistakes. That means tan of 11 pi over 6 is the same as tan of pi. Sorry, -1 times tan of pi over 6. So let me just put the fractions where they should be, like that, and like that. And it always helps to just put a bracket around these. It will, especially when we start manipulating these. Okay, let's see if that's true. Pi divided by 6 is equal tan. Positive, it's always positive. It came out wrong, by the way. That's not pi over 6. So always clear your calculator. Pi divided by 6. Trigonometry. Tan. Okay, it's saying it's that. I don't think that's accurate. But pi divided by 6. Try it again. Oh, here's why. I was in degrees. So, and now I'm going to hit tan. There we go. That's it. Now I'm going to take 11 divided by 6 times pi equals. Now I'm going to take the tan of that. And I get the negative version of the same number. So that means this, to make this equivalent, I would have to multiply it by -1. So pi, clear, make sure you're in radians. Pi divided by 6 is equal to this. Find the tan first before you multiply by -1. Now multiply by -1. I've made the result equivalent by multiplying it by -1. That's what equivalent means. The left side must match the right side. If this one comes out negative and this comes out positive, they are not equivalent. So I must adjust the positive or negative. But it's step 1. Here's the steps. Step 1 would be ultimately learn radians, degrees. Step 2, find your acute angle. Step 3, use cast to see if you must multiply by -1 or not. That's all it comes down to. So here are your steps on the screen. Make it a little bit bigger. There's your steps on the screen. And that will work every time. What about an alternative equivalent? Well, if I look at my alternatives here, I can see that right there, tan is equal to cotangent of that. So I know my tan. Let's take my acute angle. So we're going to take tan of pi over 6. But remember that we're multiplying it by -1. Is going to be equal -1 times tan of, what does it say over there? It says take pi over 2 and subtract pi over 2. Now this might be the exception because I think we're going to get, it's equal to the cotan of this. Oh yeah, that might work. So pi over 2 is the, I got it wrong. We're doing -1 of pi over 6 is equal to cotangent of pi over 2 minus pi over 6. And the negative here just stays outside. It doesn't apply to the angle. And this, all I've done is use this right here. This is the tan I have. I'm trying to find a cotan equivalent. So if I take pi over 6 and pi over 2 minus pi over 6, I have to make my left fraction have the same denominator, so I multiply by 3, top and bottom. So I get 3 pi over 6 minus 1 pi over 6. I get 2 pi over 6. And you always want to simplify. This can be simplified. So I get pi, 1 pi over 3, or pi over 3. Which means that tan of negative 1 pi over 6 will be equal to negative 1 times cotangent of pi over 3. So that means that this here is also equivalent to negative 1, because we've got to make a negative of the cotangent of pi over 3. Let's see if that's true. Will I get the same value of pi over 3? Make sure you're in radians. Pi over 3 for cotangent. Oh, try that again. I hit the wrong one. Pi over 3 equals times negative 1. Or I can just make it negative by pressing the negative button. And now I'm going to take, oh shoot, you don't multiply the negative 1 there. That's 3 mistakes in a row. Pi divided by 3. Let's find the cotangent. I get 0.5755. Now remember, I'm going to multiply by minus 1 at this point. But I might as well just leave it as is and just see if I get the same values. Now, will pi over 6 tangent produce me the same value? And I think you'll remember that it did. Yep. So that means I found, the whole point is to get the same result here. So that means I found an equivalent that negative 1 times tan of pi over 6 is the same as negative 1 times cotangent pi over 3, which is the same as tan of 11 pi over 6. So you found 3 equivalents. And they're all like that. You can stop the video, by the way, at any time, but I'm going to keep going for negative angles. And I'm going to just skip these. I might do one of, yeah, I don't have to, because now we're dealing with a cosecant. So this should help with all the others, because all the others are the same. What is a negative angle? Okay, so if I draw my unit circle, a negative angle, so principal angles always go this way, all the way around. Negative angles go this way. So this is a negative angle of pi over 3. So if I draw my principal arm, this is my principal arm. It's negative pi over 3. That's the angle. Great. What are some equivalent angles in there? Well, I know that this is also the acute angle because it's there. Now, technically, the acute angle is always a positive, so it's not negative pi over 3. But the acute angle equivalent, is always positive. Therefore, the acute angle equivalent is pi over 3, but positive. Now, it's clear that I'm going to have to multiply some things by a negative 1 to get the same value. But first, let's figure out what we're dealing with. Now that we figured out the acute angle, we go to the next step, cast. C-A-S-T. Wait a minute, we're dealing with cosecant. So here's where we have to understand that cosecant is the same as 1 over sine. So the cast rule here will apply to sine. Is sine positive here? No. Sine is negative, which means cosecant's negative, because 1 over a negative number is still going to be a negative number. So that means cosecant of this value here is going to be a negative value, but cosecants of these acute angles are always positive. So that means I will have to multiply it by negative 1. Let's find an equivalent angle. Well, I can say that the cosecant of negative pi over 3 is going to be the same as negative 1, because I know the acute angles are always positive, and this is a negative value, times the cosecant of the same angle, but positive, pi over 3. Let's see if that's true. Pi over 3, by the way, is the same as 30 degrees. So we should do it in 30 degrees and radians. But let's take pi. We're going to divide it by 3. We're going to make it a negative angle because the negative is inside the angle, which means the angle itself is negative, or the radian's negative. And then I'm going to take the cosecant. Trigonometry, I have a cosecant button right there. So I get this negative value. And by the way, that makes sense because I said it would be negative, and cosecants can be above 1. Cosecants and secants can be above 1. And actually, they'll always be above 1, I think. Yeah. Cosecants and secants will always be below -1 or above +1. Unlike sine and cosine, which will always be below +1 or above -1. Okay, let's memorize that. That's my actual cosecant value for -pi/3. It's a -1.5. Let's find the cosecant for pi/3. That's the acute angle that we're looking for. Let's hit cosecant. Well, we get the same result, I think, except this is positive and that one's negative. So therefore, I have to multiply my acute angle by -1 to make it equivalent. And that's an equivalent. But what if we wanted to find an alternative equivalent, like here? Well, I know that my cosecant of any angle is equal to my secant with pi/2, which is 90 degrees. Notice they're all 90 degrees. That's because in a unit circle, in a right angle triangle, when I create a 60-degree angle triangle here, I'm creating a 30-degree triangle here. It'll have all the same values, x and y. It's just all their cosines, and their signs will switch. We'll get more into that later, but for now, just trust that this is true. And I'm going to say, okay, since I have my cosecant, and I'll use my acute angle, it's -1 times it of plus pi/3. It's going to be the same as my secant times -1 of pi/2 minus pi/3. Well, I have to cross multiply. I get 3 pi/6 minus 2 pi/6, and I get pi/6. So let's see if the secant of pi/6 multiplied by -1 is the same as the cosecant of pi/3 multiplied by -1. So I'm going to take pi, I'm going to divide it by 6. Make sure you're in radians. So I'm going to take a secant of this, and I'm going to multiply it by -1 and see, and I think you'll remember already that it's the same thing. So that's my secant of pi/6 multiplied by -1. Now I'm going to take pi/3, pi divided by 3, and I'm going to I'm going to multiply it by, I'm going to take its cosecant and multiply by -1, and I think you'll notice they're the same value. So I found another equivalent, which means cosecant of -pi/3 is the same as -1 times cosecant of pi/3, which is the same as -1 times the secant of pi/6. And since pi/6 is an acute angle and this is an acute angle, we have answered this question using acute angles.